Welcome to the DIY Honda Garage channel. In this presentation, we will be focusing on the diagnosis and troubleshooting of DTC P0717, which indicates an issue with the input turbine speed sensor A circuit not signaling properly in the 2016 to 2021 Honda Civic. This fault is specifically associated with the continuously variable transmission (CVT) system within the vehicle. Understanding this diagnosis involves several components working in unison, including the torque converter turbine speed sensor and transmission control module (TCM). The torque converter turbine speed sensor is responsible for monitoring the speed of the turbine within the torque converter to ensure optimal transmission operation. This sensor sends voltage signals to the TCM, which interprets these signals to manage gear transitions effectively. Any disruption in this communication may trigger DTC P0717, indicating a circuit issue. Careful review of the electrical connections and sensor functionality is crucial for accurate repair. DTC P0717 is specifically related to the input turbine speed sensor A, which monitors the turbine speed in the continuously variable transmission system of the Honda Civic. The main function of this sensor is to provide feedback to the transmission control module, TCM, about the current speed of the turbine. This information allows the TCM to adjust shifting patterns for optimum performance. The sensor is typically located near the torque converter and connects directly to the TCM via a 3P connector. Any failure, such as an electrical fault in this circuit, can lead to a no-signal condition, resulting in the DTC being triggered. Recognizing its location and function is vital for effective troubleshooting and repair. This issue does not stem from mechanical problems within the transmission, but is purely electrical in nature. The primary causes for DTC P0717 include various electrical circuit problems that obstruct signal transmission from the torque converter turbine speed sensor to the TCM. Loose terminals or poor connections are often culprits, as they can prevent the proper flow of signals required for vehicle operation. Additionally, the failure of the input turbine speed sensor itself could lead to a non-signaling condition, thereby triggering this diagnostic trouble code. It is essential to isolate each potential issue systematically, starting with electrical connections and moving on to sensor functionality. Understanding these possible causes will allow for more directed and effective troubleshooting, ensuring that the root issue is addressed accurately. When DTC P0717 is triggered, various symptoms may present themselves related to the vehicle's performance. One of the most noticeable effects is a decline in transmission functionality, which may manifest as erratic gear shifts, shuddering, or overall sluggish acceleration. Drivers might also observe warning lights illuminated on the dashboard, indicating a fault within the transmission system. These symptoms often create a more significant driving discomfort and can impede safe vehicle operation. Recognizing these symptoms early can prevent further damage and aid in prompt repairs. It is advisable for drivers experiencing these symptoms to consult technical assistance quickly, focusing on the electrical connectivity and sensor health. The first step in troubleshooting DTC P0717 involves verifying the problem through a series of diagnostic actions. Initially, the vehicle must be turned to the on mode to initiate the diagnostic process. Following this, utilize the Honda Diagnostic System, HDS, to clear any existing diagnostic trouble codes, DTCs, from the system. This process ensures a fresh start for further diagnostics. After clearing the DTCs, the vehicle should be lifted securely to allow for safe access to the wheels and transmission underneath. Ensuring that all four wheels can rotate freely is critical for the next stages of troubleshooting. These preliminary steps help confirm whether the fault is persistent or if it is an intermittent issue. In the second troubleshooting step for DTC P0717, first, turn the vehicle to the off lock mode to ensure safety during the diagnostic process. Next, the torque converter turbine speed sensor 3P connector needs to be disconnected. This action isolates the sensor from the circuit, allowing for accurate measurement. With the connector disconnected, the vehicle should again be turned to the on mode, allowing for voltage testing at designated test points. It is essential to measure the voltage between test points as indicated. Specifically, at test point 1, torque converter turbine speed sensor number 2, and test point 2, body ground. An appropriate voltage reading of about 5 volts indicates that the signal circuit is operational, while any deviation from this value may prompt further investigation into the wiring and connections. During the third step of troubleshooting, an open wire check is crucial for the VCC2 line. With the vehicle still in the on mode and the torque converter turbine speed sensor 3P connector disconnected, measure the voltage again, focusing specifically on test point 1, torque converter turbine speed sensor number 3, and test point 2, body ground. A proper voltage reading of around 5V confirms that the VCC2 wire is functioning as it should, indicating no open circuits in that path. However, if the voltage reading falls short, it suggests a fault that necessitates repairs. Addressing any open conditions in the VCC2 wire between the sensor and the TCM is pivotal to re-establishing proper electrical signaling. This step plays a fundamental role in identifying the underlying issue that triggered the DTC. In the fourth troubleshooting step, a thorough check of the torque converter turbine speed sensor is essential. Again, while in the on mode, the vehicle technician needs to measure the voltage between specific test points, particularly at test point 1, torque converter turbine speed sensor number 1, and test point 2, torque converter turbine speed sensor number 3. This measurement will help ascertain whether the sensor is receiving and transmitting correct voltage levels as required. A reading of about 5 volts suggests that the sensor is operational and intact. If the desired voltage is present, the next step is to replace the torque converter turbine speed sensor, which is likely faulty. In contrast, if the sensor does not meet the expected voltage levels, it signals that the sensor itself is functional and directs attention to checking the wiring or connections between the sensor and the TCM. The next troubleshooting step focuses on identifying potential shorted wires within the circuit. Begin by turning the vehicle to the off lock mode for safety purposes. Disconnect the TCM 50P connector, isolating the transmission control module from the circuit. This step is vital to prevent backfeeding electrical signals during testing. Using a digital multimeter DMM, check for continuity between test points that involve the torque converter turbine speed sensor 3P connector number 2 and body ground. The goal is to confirm whether there is an unintentional connection to ground, which may indicate a shorted wire. If continuity is confirmed, this signifies a short to ground in the NT wire, thereby necessitating repairs. However, if there is no continuity, it indicates that the NT wire has not shorted, so further tests will be warranted in the next step. In the final troubleshooting step, checking for open wire continuity is critical for the NT line. With the vehicle still in the off lock mode and both the torque converter turbine speed sensor 3P and TCM 50P connectors disconnected, the next phase involves testing for continuity at the specified points. Specifically, check continuity between the torque converter turbine speed sensor 3P connector number 2 and the TCM 50P connector number 49. If continuity exists, it confirms that the NT wire is functioning correctly. At this stage, additional resources should be consulted. including any authorized service information related to DTCs, or consider substituting a known good TCM. If substituting resolves the issue, it suggests that the original TCM required replacement. Conversely, if there is no continuity, it confirms an open wire, necessitating repairs between the sensor and the TCM. After completing the necessary repairs based on the above troubleshooting steps, it is crucial to perform final verification to ensure that the issue has been resolved. Start by confirming that the diagnostic trouble code, DTC, has been successfully cleared from the system. Following this, a test drive of the vehicle is imperative to evaluate for any lingering symptoms or warning lights. Monitoring the vehicle's behavior during the drive allows the technician to validate that the transmission operates as intended and confirms that no further issues arise. Properly functioning systems after repairs is essential for assuring the driver of vehicle safety and performance. If any symptoms resurface or new DTCs appear, further diagnosis may be required. To minimize the chances of encountering DTC P0717 and related issues, incorporating preventive maintenance practices is vital. Routine inspections of electrical connections, especially those related to the torque converter turbine speed sensor and TCM, can help identify any potential weaknesses before they escalate into significant faults. Scheduling regular electrical system checks allows for early identification of frayed wires, loose terminals, or degradation that could impair functionality. Promptly addressing any detected issues ensures a more reliable operation of the transmission system. Ultimately, a proactive approach to maintenance not only enhances vehicle longevity, but also promotes driving safety and enhances performance. In conclusion, DTC P0717 highlights an issue specifically related to the input Turbine Speed Sensor A circuit, emphasizing the need for careful electrical troubleshooting. Understanding its implications, such as potential transmission performance issues, helps in promptly resolving the problem. The focus on electrical integrity is paramount, as mechanical failures are not a factor in this particular DTC. By following the systematic troubleshooting steps outlined, technicians can accurately diagnose and repair the underlying issues that cause the DTC to trigger. Furthermore, implementing regular preventive maintenance can significantly reduce the likelihood of these types of faults arising in the future, leading to a better overall driving experience. Please like and subscribe to the channel. See you next time.